Welcome to Chapter 4, Section 5, Geometry students. Today we are going to talk about dilations, which basically is whatever, what happens when you look through glasses or a microscope or a telescope. Dilations can increase the size by a certain scale factor or decrease the size by a certain scale factor. The nice thing is you just have to do basic math. Now, another resource that I want to share with you. So can you go to our textbook webpage? But before we go to the textbook, right, we click this to go to the textbook when we log in. I want you to go to my page and go ahead and click Geogebra. Now, you can go to geogebra.org, as you can see up here, if it's not working through the textbook or through the links we take to get close to the textbook. And we're going to take a minute to let it load because apparently it wants to do that. So with GeoGebra, we can actually create the shapes that Desmos doesn't create. Remember on Desmos, we were just doing the points. Here we can actually make it look like a triangle or make it look like, well, whatever it's supposed to be. So go ahead and click Start Calculator. And we are on page, 208. All you got to do is figure out what's 12 divided by 3. And that's, 3 divided by 12. You put the new length on top and the old length on the bottom. So you're going to want to go ahead and read example 1 and then go ahead and do monitoring progress number 1. Well, actually, you just simplify 3 over 12. Simplify 3 over 12. 3 over 12 is not an appropriate answer. And it would be a reduction because you're shrinking. All right. We're on page 209 in the geometry textbook. And examples 2 and 3 are great. The coordinate rule at the top is also important, but you really, like I said earlier, just multiplying by a certain number. All right, so let's go down to number 2. And I want you to practice this. So when I'm done typing it in, go ahead and you can pause the video and practice yourself on GeoGebra. So we're going to go to shapes, well, tools, and we're going to put some points down. So we're going to graph triangle PQR and its image after a dilation with a scale factor of K. So number 2 says that P is at -2, -1. So we go ahead and click. Q is at -1, 0, and R is at 0, -1. And to make it look like a beautiful triangle, something that I was missing from Desmos, we can go ahead and do that. Don't worry about the letters that show up. Okay. If you want to, by the way, you can click select objects, select the whole thing, and change the color to whatever you want. Okay. The scale factor is 4, which means we're just going to take every coordinate and multiply by 4. So -2, -1 becomes -8, -4. Notice I clicked point again. -1, 0 becomes -4, 0. Now, technically, this would be A prime or P prime, because this is supposed to be P, Q, R. So P prime, Q prime, and then we'll do R prime. 0, -1 becomes 0, -4. And there you go. Doesn't this look like this was a dilation? We enlarged it by 4. We enlarged every coordinate by 4. Like it says, that's the scale factor. One thing to keep in mind, to make it a true dilation, we're actually, well, I'm not going to move anything, but we're standing at the origin. And we're looking towards the 3rd quadrant. So we're looking towards the bottom left. And we see an object, triangle PQR, right in front of us. And we dilate it, we enlarge it, we dilate it 4 times by a scale factor of 4. So that's where it's going to end up, where this says triangle DEF would really be P prime, Q prime, and R prime. Okay, so pause the video. Go to GeoGebra, try it yourself. Draw it on your in your notebook if you want to, but now's your time to actually try it. And you should be back by now. I would imagine you just paused my video, paused time, and we're going to go on to number 3. So for number 3, we have more points. We got obviously 5, -5, 10, -5, and 10, 5. Okay, and now we can make it look like a actual triangle. Okay, so this is the, excuse you. Well, I guess now I can figure out, I can either figure out how to, oh, there we go. Undo, undo, undo. Excellent. See, learn something. All right, and boom. All right, so this was triangle PQR. I'm just going to double check. 5, -5, 10, -5, and 10, 5. We now have a scale factor of 0.4. So get your calculator out, multiply by 0.4, or do some mental math. 0.4 is 2/5. So you could then just multiply everything by 2/5. So 5, -5 times that by, so 5 times 2/5 is 2. -5 times 2/5 is -2. So this would be P prime. This A point went over here. All right, we got 10 times 2/5 is 4. And -5 we know is right here. And point R, so R prime, 10 times 2/5 is still 4. And 5 times 2/5 is 2. And here we go. All right, so remember we're standing at the origin, and way in the distance is this very large triangle. And then we dilate it, the scale factor of 0.4, so it's a reduction, and it becomes smaller and closer, right, to these coordinates. Okay, all right, you can go ahead and pause the video, try it. Also, try page 210, number 4. All right, it's a scale factor of -2, so it's gonna look different. Something's gonna happen, but you're gonna do the math to figure out what happens, okay? And when you come back, we're actually gonna be on page 211. So pause, do 209, number 3, and then go ahead and do page 210, number 4 on your own. You can look at the example above if you need to. We're not doing constructions. All right, and now that you're back, I just want to make sure that some math is clear, okay? So we don't need GeoGebra right now. We are on page 211. I'm going to switch to here. So we're on page 211, some math from before. And I want to do number 6 and number 7 with you. Now that will involve you reading example 6, but we'll get to that in a second. Page 211, number 6. All right, so an optometrist, oh, that actually gave me a headache, just shaking my glasses, dilates the pupils of a patient's eyes to get a better look at the back of the eyes. If you've been to the eye doctor, that should have been done to you. So the pupil dilates from 4.5 centimeters, oops, sorry, oh, big eyes, 4.5 millimeters to 8 millimeters. So they're asking us, what's the scale factor? Now I mentioned this earlier with number 1, but I just mentioned it. Here's what you need to do. You put the new length on top, the old length on the bottom, okay? So we're gonna do 8/4.5. Now, just a reminder, or if you don't know this, you can't make fractions with decimals in them. That's like disgusting. So how are we gonna get rid of the decimal? Well, I'll multiply this by, you could do many things. math works, math makes sense, right? You can multiply both by 10 and then reduce, or well, 4.5 times 2, kids, is 9. So if we're going to multiply by 2 on the bottom, let's multiply by 2 on the top. So we're multiplying by 1, not changing the value. Bada bing, bada boom, the scale factor. This is your, that's supposed to be an arrow. That's your K. That's the scale factor, 16 over 9. All right, so new length, okay, so it went from 4.5 to 8 millimeters. So 8 millimeters goes on top, 4.5 goes on the bottom. The optometrist dilated our eyes by a scale factor of 16 over 9. You can go ahead and figure out what the decimal is if you want to talk in terms of decimals on your own, but we're not doing that here, okay? All right, but speaking of decimals, okay, you might want to pause, read example 6, or you might want to just ignore that advice and go through and then get a little lost and then pause and then rewatch this again. So pause, read example 6 right now about the spider. And when you come back, all right, so we have a spider and it's under a magnifying glass, correct? So the spider under the magnifying glass is 12.6 centimeters long. We know that the spider is shorter than 12.6 centimeters because it's under the magnifying glass, so we're seeing a larger image, right? All right, now, according to example 6, the magnifying glass magnifies everything 6 times. So what do you think we're about to do? If we take the object, multiply by 6 to get the dilation, let's divide it by 6. Well, 6 goes into 12 2 times. 6 goes into 6 1 times, 1 time. And so the answer is that the spider for number 7 is 2.1 centimeters long. Let's just go back a minute. Okay, this was like mental math, kind of using some problem solving skills. If you want to go to this formula, new versus old, sorry, new over old versus, this isn't a game, is equal to your scale factor. Okay. We know that the spider, the new length of the spider under the magnifying glass, we are seeing a dilation of 12.6 centimeters. We know that the scale factor is 6. So we're really just looking for the old value. You can put a variable in here if you want. I don't, doesn't matter, right? So 12.6 divided by the old value is equal to 6. So we're going to multiply the, well, kids, you're in geometry, not algebra. Let's just switch these two values, right? We're going to multiply old over here. We're going to multiply 6 over here. And we end up with what I just did up top. Okay, and I'm just proving to you that math makes sense. The old value is going to be 12.6 centimeters divided by the scale factor of 6. Okay, all right. You should take some notes on these. I just wanted to make sure the math for this is clear. New over old is equal to your scale factor. You'll obviously have practice problems coming up.